All right, so welcome. This is our review of chapter 3. All right, so this is the material you'll need from chapter 3. There's an awful lot in there. I'm not going to go over keystrokes, and I will note that while there are a lot of formulas in chapter 3, we really only use directly a handful of them. Others are already built into your calculator. So, chapter 3.1, measures of center. So we have the mean, median, mode, and mid-range. The first two. Calculator. The mode by observation. My data sets are nowhere near large enough that you can't look at them and figure out exactly what the mode is. It's the most common data value. I believe everything in our exams and quizzes really never gets more than 10 to 15 data points at the most. The calculator works for the mean and the median. The mid-range, however, has a formula. Min plus max divided by 2. So, the mean and the median, calculator. The mode, observation. The mid-range, the only one with a formula. And we grab the min and the max from our calculator. Our keystrokes, I'm not going to talk about the keystrokes, but I will note that the TI-84 uses the one variable stats command. And you can find plenty of detail here on the website, on the Canvas course shell. The rounding, we round to one more decimal place. Than the data. And that is only for the mean, median, and mid-range. We just report the mode. So, one more decimal place than the data. That's good for the mean, median, and mid-range. But we just report the mode because that's like a election out. Probably a couple of other things in there, but those are the main ones. And again, I do expect your calculator to be able to do these calculations for you. By the way, I do ask people to select the correct screenshots from a list of screenshots from a TI-84. So you truly do need a TI-84. All right, that was 3.1, measures of center. (3.2) measures of variation. It is truly the most important chapter in the book. Variation governs gosh darn near everything we do with inferential statistics, and even just plain old regular statistics where we report. So measures of variation. Now, we have a couple of them. We have the standard deviation, we have the range, and we have the variance. All of them are found by your calculator either directly or with a bit of work. The standard deviation, you need to make sure whether you are working with a sample or a population. There are different numbers there. That's S and that's sigma. And we use our calculator to do that. The range, we can use our calculator to some degree, but I need a formula. The range is max minus min. So I need a range formula, but I get the max minus min from the calculator when I find my one variable stats. The variance is the one that's most difficult. That's either S squared or sigma squared, and we need the var key to do that. Round. The same one more decimal place than the data. And what else can I say about that? Oh, the TI-84. Same place, one variable stats. So when I find my mean, when I find my median, I also find the standard deviation, and I get access to the range and the variance with a little bit of work. There's a couple of other things that are in section 3.2 that are very important, but let me emphasize first that we like our calculator for the standard deviation. We need a formula for the range, and I need the var key for the variance. Same rounding, one more decimal place, and we need that one variable stats key. But as I say, there's a couple more things in chapter 3 of import. We want to be able to identify scores, values, whatever it is we might be measuring that are significantly high or low. So we have a way to do that. It's not very difficult. It's rather arbitrary, I got to admit, and different situations really do change this particular rule. But for us, it's pretty well set in stone. These are values that are at least 2 standard deviations above or below the mean. That means I need the mean plus or minus 2 standard deviations. I have 2 formulas because sometimes I work with data from a sample, sometimes I work with data from a population. On a number line, the mean is in the middle, whether it is X bar or mu. 2 steps up, SS, 2 steps down, SS, or perhaps sigmas. There gets me to my X bar plus 2S, mu plus 2S. Down here at the other end, we have X bar minus 2S, mu minus 2S. The stuff over here is way high, man. The stuff over here is way low. And as I say, it is defined in terms of interval notation. So we do include those endpoints. And that is the way we like to identify high and low values. So it's also a very important component. Now, the last thing I want to mention from chapter 3.2 or section 3.2 is the empirical rule. You just saw me quote it, but I'm going to put it in real quick again. 68% plus or minus 1 standard deviation. 95% plus or minus 2 standard deviations at 99.7% plus or minus 3 standard deviations. That's our empirical rule. The thing that blows students' minds, that's difficult for them to work with, is rarely does it appear as like, use the empirical rule to blah, 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 blah. No. What you need to pick up on is the phrase normal distribution with a mean and a standard deviation. And then the questions, you can tell by the questions, percent within. Just like we had in that question in the chapter review. So the wording here also plays a big role. So that empirical rule, you got to pick up on the normal distribution phrase. There has to be, by the way, I cannot ask you specific questions about the empirical rule like that question in the review if I don't give you a mean and a standard deviation. I can ask you a generic question about the empirical rule. Given a normal distribution, what percentage of scores lie within 1, 2, or 3 of these little guys? But in general, to answer specific questions, you also need a mean and a standard deviation. Now, there's a couple of things that I do not test upon coming out of chapter 3, 3.1 and 3.2 in particular. So there is no Chebyshev's rule. I don't cover it in the problem set. And by the way, if a problem squeaks in there from the Chebyshev's rule, I apologize. I'll try to get that out of there. It doesn't appear on any quizzes or an exam. So there's no Chebyshev rule. And there are no direct questions about grouped data. But maybe extra credit I am going to go over those keystrokes. I'll be honest, if I put that in there as extra credit, so few people get it that I kind of feel bad about putting it in as extra credit. I tend to think that extra credit should be something that the exam or quiz is really just a bit too long for, and it really could be in the regular quiz. It shouldn't be something that's so freaking hard that no one in their right mind could get it. But that's honestly what happens with the grouped data. It's because it's kind of calculator heavy, and there's not a lot of intuition there. So that's the end of my review on 3.2. Let's take a look at section 3.3. Measures of position. Okay. So of all the sections we do in chapter 3, this one honestly should be the most straightforward. There is some calculator keystroking involved, but the calculator really does try to help you out a lot. So measures of position, and there's a formula involved. We got the z-score. That is the number of standard deviations a given score is, either above or below the mean. The z-score can be positive or negative. It's got a special formula, x minus x bar over s, or x minus mu over sigma. We can use the z-scores to define significantly high and low x scores. So x is significantly high or low if it is less than or equal to -2 or greater than or equal to +2. So on the z-score number line, scores that are out here are significantly high and significantly low. And you're probably thinking this picture looks exactly like the picture for significantly high-low scores back in 3.2, where we use ±2 standard deviations. And the reason for that is it's exactly the same detail on a different scale. It's kind of like if you measure distance and went from miles to kilometers. The actual distance between my house and Salinas wouldn't change, but the number would change. So it's really the same detail or the same info as mean ±2 standard deviations. And we use it a fair amount coming up. It turns out to be quite important. It's kind of an interesting backdoor way in which it becomes important. It's not really used directly for the most part with actual sample X value scores. It's a more global statement. It's where the math gets really theoretical, which honestly for my students is not a bad thing. We don't dabble too much in theory, and the theory can honestly be appreciated through some reasonable graphs. So this turns out to be quite important. Now, in addition to that, we had the notion of quartiles. Quartiles are like the median, but the data is divided into quarters by number of values. 25% in each quarter. If I put the minimum value here, if we put the maximum value here, we have our median right here in the middle, and I know that 50% of data values are bigger than the median, 50% of data values are smaller than the median. What I do with each of those 50% is I split those little guys in half too. So I've got 25% there, 25%, 25%. Get in there, there we go. 25%. We give them names, Q1, Q2, and Q3. And those values do a couple of things for us. They're really quite important when it comes to summarizing a data set. We can get a lot of detail and information from the quartiles, and they really truly are used to compare data sets. I have some examples that I'm going to be sharing from real research journals that actually use the stuff we're starting to develop here. So we have, let me be very clear here. For our quartiles, we have the minimum, Q1, Q2, Q3, and the maximum. Those are the 5 numbers that are important for the quartiles. Sometimes that confuses students because there's 5 numbers and you think quartiles should be like a 4th thing. Or maybe you get confused by you see a Q1, a Q2, a Q3, but not a Q4. Same sort of problem there. Don't let that bother you. There's got to be 5 numbers in the data set from min to max, and then 3 in the middle, really to split it up into quarters. That's the reason that plays out that way. So we have quartiles. This gives us our 5 number summary. And that 5 number summary is just what we see there. It is the min, Q1, Q2, Q3, and max. By the way, on your calculator, this is labeled MED, and it's in 1 variable stats. So that 5 number summary contains, not surprisingly, 5 numbers, although one of them is a little bit misnamed by Mr. Calculator. And we use our 1 variable stats to find it. And that brings us to pretty much the last thing from chapter 3 that we really focus on from that material, and that is the box plot. BBQ. I'm actually smoking some ribs right now. Box plots. So to find a box plot, we need the quartiles. And the box plot looks like this in a very generic fashion. Sometimes the things coming off the little ends are called whiskers. In fact, it used to be called the box and whisker plot, which I thought was just so cute. And we've got the same 5 values from the 5 number summary: min, Q1, Q2, Q3, and max. And it's important to note that they each contain, each portion there contains those 25% of the data value that we just got done defining. And we'll use our calculator, and we use the stat plot key. I went through those keystrokes the other night. The video is up there under our office hour lectures. So it's the box plot. So cute. And it's the stat plot key. And here again, do realize that I will be giving you a data set. I will show you a number of different TI-84 stat plot pictures, box plots, and you'll need to pick the correct one. So you'll have to be able to make your calculator do the box plots. Now, very much like 3.2, there's a couple of things I just do not cover out of 3.3. One of them we sort of get to a little bit later. Right now, it really is difficult to get after some of this. So there are no modified box plots. I think if we were doing stuff face to face and we had some sort of lab, I would take a look at this because it's actually does get used a fair amount. But the keystrokes are a little bit more involved, and there's a little bit of a disconnect between your calculator and the text, but not much. So there's no modified box plots, and there are no percentiles. I'll talk about percentiles at some point, but I really need to wait until we have more robust data sets. Right now, it's very much like, I'll even just tell you, it's like quartiles, but, and as you might expect, there's there's min, and then the first 1%, 2%, all the way out here to max percent, where you finally get to 100%, somewhere out there. So it's very much like quartiles, but at the percentage level. Right now, it does not make much sense to me in the context of our course to go ahead and go down that road. There's other things I'd rather get to. We will talk about them at some point, but we're going to wait until everyone has just a little bit more experience under their belt. So that brings me to the end of my review for chapter 3. Are there any questions? I haven't looked over here in a little bit. I don't know what's going on in the chat. Could be crazy in there. Could be nuts. No, nothing. Okay. All right, it's 4:42. Maybe I will go through the keystrokes for working with grouped data. It may appear as an extra credit assignment at some point. I don't think I'm going to include it as an extra credit question on anything anytime soon, but I might include it as an extra credit assignment. Yeah, people get points hungry near the end of the semester, and that's something I can bring out. All right, so let me go ahead and give you some data, and then we'll talk about the keystrokes involved. I kind of like it because it enables us to use our calculator in a couple of different ways that we haven't done so up until this point. All right, so if we've got grouped data, there are no actual scores. So in some sense, whatever it is we do here is a real workaround, although the keystrokes are usable for doing other important things, which is why I like to mention it. So if we take a look, and let's see, age, frequency, and let's see, 20, 30, 40, 50, 29, 39, 40, 50. All right, so let me put some values in there. 6, 3, 7, 2. All right. Now, when we work with group data, it's important to realize whatever it is I'm working with, I am not working with actual scores. And let me tell you what the issue is here. Here's the problem. Let's just take the first class alone. There are 6 scores in that first class, and they fall in a range. They could be anywhere between 20 and 29 inclusive, which means they could be 20, they could be 29. So if I'm going to make a calculation for something like the mean, I have to realize that I would be getting different values if they were all 20 or if they were all 29. I don't know. Chances are it's all spread out through that little range, but I have no idea what the actual scores are. So there's no score, so we make an assumption. We assume the frequency for each class is equal to the class midpoint. So, in other words, if I find the class midpoint, and for our example here, I'm just going to put them in. I'll talk about where they come from. You can review that. It's back in chapter 2. I add the two numbers together and divide by 2. This is where we get the midpoint. All right. So the assumption we make is that everyone in class number 1 is exactly 24 and a half years old. How many people are in there? 6 of them. How many people are in class the 30 to 39? There's 3 people there. We assume they're all 34.5 years old, all of them. We don't know, we make an assumption. And I do that for the other ones. So this brings us now to the first instance where we have data that lives in 2 places. I have data here in my frequency list. I have data here in my midpoint list. I need 2 lists. I need a list 1 and I need a list 2. So on my calculator, I'm going to go back over here to my calculator. Let me get him up and running. If you want to try to push your buttons along with me, it sounds a little funny, but so be it. You certainly can. And we are recording this, so it will be up in our shell later tonight or early tomorrow. All right, let me clear my screen and find you guys again. There we are. Okay, let me share. There we go. All right, so I need my data now in 2 distinct places. So I come to my stat key, I select enter and edit, clear, enter, clear, enter. Remember, you've got to highlight the list name to clear the list. Some of you will actually end up removing lists completely from your calculator. You'll get all freaked out. Don't worry about that. Just come to me and I'll tell you how to put them back. So the first list has 24.5, 34.5, 44.5, 54.5. That's my first list. List number 2, 6, 3, 7, and 2. All right, so I've got the class midpoint in list 1. I've got the frequency in list 2. So I come back to stat, find my calculator. It's still 1 variable stat. Sometimes people think it should be 2 because there's 2 lists, but no. Now, we're going to show you a key that's going to be important later on. It'll kind of go away in terms of importance for a while. We'll forget, but then I'll remind. So I go second, list 1, and then I pick up the comma key. Note the comma key. It's right up above the 7 key. I need that. Then I pick up second, list 2. I'll hit enter, and there we go. I'm going to go through those keystrokes again. By the way, the mean of those ages was 37.3, 1 decimal place there. 2 decimal places actually, because I had 24.5 as my data value. So 37.28. We got the standard deviation. I would need to know if I have a sample or a population to know which one of these numbers I need. Down below, I've got my min, Q1, Q2, median, Q3, and max, I've got my 5-number summary. So as I say, let me go through those keystrokes again. One variable stats, second list 1. Don't forget Mr. Comma, you'll get an error if you do, an error message. Mr. TI will say, no, I can't do that. Slap you down. So there we go. Now, some of you may have your calculator set on the stat wizard mode. So I'm going to change the mode on my calculator. Down here, stat wizard. I'm going to turn them back on. I don't care for this option, honestly, but I'll leave it on for now. One variable stats. So second, I know it already says list 1. I don't really need to enter it there. List 2 for the frequency. Enter once more. You come up against calculate. You blow on it once for luck. And there you go. So those are the keystrokes for graphing, or excuse me, finding the summary statistics for grouped data. But as I say, it's kind of a set of specialized keystrokes. Some of the stuff we use in the future, but usually we have access to the raw data. There's no way I would want to do any sort of real world important analysis unless I actually had the scores in front of me, man. I don't want to make the kind of assumptions that need to be made in the class midpoint argument. So let me stop my sharing. And let me ask, are there any questions on that, Ernesto and Ashley? I don't see any. No one's unmuting. No one's chatting. All right. So there's our review for the chapter 3 material. I'm going to stop the recording.